Imagine standing in a dense South African forest, specifically right at dawn.
Oh, yeah. The best time to be there.
Exactly. The air is damp, heavy with mist rolling off the Indian Ocean. It's pushing up into this towering cathedral-like canopy of the garden route.
Right. And it's dark. You can barely see a thing.
Yeah. Before you could even adjust your eyes to the low light, you were just hit with a wall of sound.
It is genuinely deafening.
It really is. It's this competitive, aggressive, overlapping dawn chorus. But the loudest, most dominant voice in that entire forest, the one cutting through the physical clutter of millions of leaves, is a creature you will almost certainly never see.
Which is wild, because today we are basically tracking down a ghost.
Right. It's the ultimate paradox, isn't it?
It really is. I mean, we are dealing with an animal that has evolved to be a total phantom visually, while simultaneously demanding to be, the center of attention acoustically.
We are, of course, talking about the olive bush shrike.
Yes, the olive bush shrike. Such a fascinating bird.
It's elusive. It's highly vocal. And as we dug into the research for this deep dive, we found out it's shockingly adaptable.
Yeah, highly adaptable. But to piece together the life of a bird that spends its entire existence playing, high-stakes hide-and-seek in the upper canopy, well, we had to pull from a massive, really eclectic stack of sources.
We really did. We couldn't just rely on one discipline here.
No, definitely not. Understanding a creature that flat-out refuses to be seen requires triangulating data from wildly different angles.
Right. So we pulled firsthand, boots-on-the-ground field reports from birding tours like Avian Leisure.
Which is great, because that gives us the practical, totally frustrating reality of actually trying to spot this thing in the wild.
Exactly. And then we cross-referenced that with continent-wide citizen science data from the SAVAP 2 Atlas.
Yeah, the big picture stuff.
Then we dove into this really fascinating master's thesis by Nasifi Batani from the University of KwaZulu-Natal.
That thesis is incredible. It gets into the hyper-specific biomechanics of how this bird actually functions physically.
It's mind-blowing. We've also got a rigorous ecological study on forest fragmentation out of Durban. Oh, and we even have transcripts from a local birder's YouTube channel.
Lynette Rudman, right.
Yeah, Lynette Rudman. She captured a behavioral quirk that honestly sounds supernatural. We'll get to that later, but it is wild.
It really is a spectrum, a macro-level satellite mapping of disappearing habitats all the way down to micro-level physical measurements.
And you need all of it, because the olive bush shrike isn't just a bird. It is a masterclass in survival mechanics.
100%.
So that is the mission for this deep dive. We are unpacking the hidden life of a shape-shifting forest specialist.
It's going to be a good one.
But, if you're listening right now and thinking, I don't own binoculars, why should I care about some rare bird? Stick with us.
Yeah, please do, because it's not really just about the bird.
Exactly. The way this creature leverages its environment, predicts shifts in the atmosphere, and negotiates with other species. I mean, it fundamentally changes how you understand the invisible networks operating right outside your own window.
It forces you to realize that a forest isn't just, a random collection of trees. It's a highly structured, highly competitive metropolis.
A metropolis.
Mm-hmm.
That's the perfect word for it. Let's actually start with that metropolis, because I was looking at the SAVAP 2 Atlas data, and it maps out exactly where this bird lives.
Right, the geographic parameters.
Yeah, and it's almost entirely endemic to southern Africa. But it doesn't just live anywhere within that region.
No, it is incredibly picky.
Picky is an understatement. The data says they are strictly confined to areas below 2,000 meters in altitude, and they demand an average annual rainfall of at least 600 millimeters.
The 600 millimeter rule.
Yes. Now, hold on. That sounds absurdly precise for biology. Does a bird actually hit an invisible wall at 550 millimeters of rain and turn around?
Well, it does sound like a rigid boundary when you say it like that. But biology doesn't respect imaginary lines on a map.
Right. So what's actually happening there?
What the bird is responding to isn't the rainfall itself. It's not measuring the drops. It's responding to what that specific volume of water engineers.
Okay, engineered how?
That 600 millimeter mark is essentially the hydrological tipping point for a very specific type of forest architecture.
Oh, so it's a structural requirement, not just like a thirst thing.
Precisely. It's entirely structural. If an area gets, say, 500 or 550 millimeters of rain, the soil just cannot support a closed interlocking canopy.
Because there's not enough water to go around.
Exactly. The trees physically have to space themselves out to survive the dry periods. And when they space out, sunlight hits the ground, the humidity evaporates, and you get an open woodland. or a savanna.
Which is too exposed.
Right. But cross that 600 millimeter threshold, especially in the garden route where that rainfall happens year-round and the whole ecosystem transforms.
Because it's constantly wet.
Yes. You get these towering yellow woods, dense understories, and a canopy so thick it physically blocks out the sun.
Wow.
The humidity gets trapped at the forest floor. It creates this dark, damp, permanent shadow.
And that shadow is the olive bushshrike's entire operating system.
You couldn't have said it better.
I mean, the Avian Leisure Report describes these areas like the Tews River coastal forest and wilderness as cathedral forests.
Cathedral forest. It's so evocative.
It really is. And the Garden Route Botanical Garden in George has this specific trail called the Mushroom Meander.
Oh, I've heard of that trail.
Yeah, the sources mention you walk down into this deep gorge over an old furrow, and suddenly the light just drops. The temperature shifts, and you're completely enveloped in this dense, tangled biomass.
And that is exactly where the bushshrike wants to be. If you take this bird out of that specific architectural geometry, say you drop it into an open savanna, its entire evolutionary strategy just completely collapses.
Because it can't hide anymore.
Exactly. It becomes highly visible, utterly vulnerable to predators, like the African goshawk, which patrols those areas.
Right.
Plus, its hunting methods become entirely useless in an open space. It absolutely needs the physical clutter.
So this bird is basically an ecological snob.
A snob.
Yeah, like a celebrity who refuses to stay in any eco-resort that doesn't have perfectly calibrated humidity and an altitude limit.
That is, well, actually, that's a pretty fair analogy. But you have to remember, this snobbery is purely functional.
Right, it's life or death.
Exactly. Living in a dense, tangled, low-light environment means you can't just be any average bird. The architecture of the forest forces a very specific architecture onto the body of the bird itself.
And that brings us to what it actually looks like, or, how it's built to stay hidden.
Yeah.
I was reading Nassif Batani's thesis, and based on the habitat, I was expecting this robust, hardy forest dweller.
Oh, you'd think so, right?
Yeah, but the physical measurements are shocking. It's practically weightless.
The biomechanics in that thesis are fascinating. Batani went into the Durban Natural Science Museum and used digital calipers to measure the exact functional traits of these birds.
And the mean body mass.
Roughly 33 grams.
33 grams. That is the weight of a standard light bulb? I mean, how does something so delicate survive in such a competitive, massive environment?
Because in the high canopy, weight is a massive liability.
Really? How so?
Well, a 33-gram body means it is light enough to maneuver through the absolute densest tangles of vines. It can land on the thinnest, outermost twigs of a yellowwood tree without the branch sagging or snapping.
Oh, wow. So it can go where heavier birds literally can't.
Exactly. It grants the bird access to microhabitats within the canopy that heavier predators or competitors simply cannot reach.
Okay, I see the advantage of being feather light. But then there's the other measurement Batani highlights. It has a gape with the width of the mouth of 8.5 millimeters, but a bill length of nearly 22 millimeters.
21.7 to be precise.
Right, 21.7 millimeters. So it's very long and narrow.
Yes. And the Biodiversity Explorer data confirms why that matters. This bird is not primarily eating fruit. It is an insectivore.
Got it.
It is what ecologists call a canopy gleaner.
A canopy gleaner. Okay, break that down for me. Because it's not just sitting on a branch waiting to catch a fly in midair. Right.
Well, flycatchers do that. They swoop out and catch things on the wing.
Right.
And it's not scratching around in the leaf litter on the forest floor like a thrush. A canopy gleaner actively hunts by moving methodically through the dense leaves high above the ground.
Just searching the foliage.
Yeah, visually scanning the surfaces, checking the undersides of leaves, and probing into the crevices in the bark.
And the diet listed in the sources reads like a literal horror movie for bugs.
It really does.
We're talking beetles, crickets, mantids, wasps, bees, and large spiders.
Yes, large, aggressive spiders.
Right. If you were hunting stinging wasps or massive spiders hiding in a curled-up leaf, you don't want to just smash your face into it.
Which is exactly why that 22-millimeter bill evolved. It operates identically to a pair of precision surgical tweezers.
Surgical tweezers. That is such a cool visual.
It gives the bird just enough reach to extract a spider from a tight crevice or to snap a wasp out of the air while keeping its delicate eyes and face safely out of range of stingers and mandibles.
So it just snipes them.
Yes. It strikes quickly, disables the prey, and consumes it all while balanced on a tiny twig hundreds of feet in the air.
You know, it makes you realize if you're walking down a trail looking at your boots so you don't trip over a root, you are entirely missing a high-stakes turf war happening 50 feet above your head.
Oh, absolutely. The canopy is a war zone.
It completely changes how I view a hike. But there is another layer to this hide-and-seek game that genuinely confused me when I was looking at this AppF2 data.
The polymorphism.
Yes, we know it hides in the leaves, but it also engages in polymorphism. Two distinct plumage forms within the exact same species.
It's one of the most fascinating things about them.
The data says one form is its normal, distinctive olive and yellow self, but the other form has evolved to look almost identical to a completely different bird.
The orange-breasted bushshrike.
Right, the orange-breasted bushshrike. I don't understand the play here. Why would you invest the genetic energy over millions of years of evolution just to dress up as your neighbor?
To understand the evolutionary gamble of mimicry, you have to look at the social hierarchy of the canopy.
Okay.
The orange-breasted bushshrike is a closely related species, but they often have slightly different dominant structures or territorial boundaries.
Got it.
In a dense forest, territorial disputes are incredibly costly. Fighting burns calories, it risks injury, and worst of all, it attracts predators.
So if an aggressive, dominant male olive bushshrike is patrolling his territory, and he sees what he thinks is an orange-breasted bushshrike,
he might just ignore it.
wow.
The mimicry acts as a form of social camouflage. The disguised bird blends into the background noise of the ecosystem.
That is so smart.
It essentially bypasses the intraspecies aggression. It's a way of saying, hey, don't mind me, I'm not a threat to your specific territory, I'm just a different bird. It conserves massive amounts of energy.
It's the ecological equivalent of putting on a high-vis vest and carrying a clipboard to sneak into a construction site.
Yes.
Nobody questions you because you look like you belong to a different department. That is brilliant.
It's a perfect strategy for a crowded environment.
But this brings up a massive contradiction for me. We have a bird that weighs nothing, so it doesn't move branches. It has surgical tweezers to hunt silently. It has evolved fake plumage to avoid being noticed. Visually, it is a ghost.
But acoustically, it is a localized thunderstorm.
Exactly. The Avian Leisure Report describes the dawn chorus at places like the Kingfisher Country Guesthouse Garden, and they use this specific phrase, audio dominance.
Yeah, they do not hold back vocally.
The report says the olive bushshrike competes with the chorister robin to completely take over the soundscape. Why would a bird that puts so much biological effort into hiding suddenly scream at the top of its lungs?
Because the very environment that hides them visually also isolates them.
How do you mean?
When you live in a cathedral forest where your sightlines are limited to, like, a few feet in any direction, visual displays are useless.
Oh, right. Like a peacock fanning its tail.
Exactly. A peacock works in a clearing, but in dense foliage, no one can see you. So if you want to claim a territory, or warn off a rival, or coordinate with a mate, you have to use a medium that can penetrate thousands of leaves and branches.
And sound is the only option.
Sound is the only option.
So it's a calculated risk, like, I'm going to give away my position, but I'm going to do it so loudly and aggressively that I intimidate anyone who might challenge me.
Exactly. It's shock and awe.
But the citizen science data points out a flaw in this. It says its calls can easily be confused with the Bach McKerrie, and again, the orange-breasted bushshrike.
Which is a nightmare for birders.
Right. It must be incredibly frustrating for researchers trying to track population numbers.
It requires an observer with a deeply, deeply trained ear. Someone who can distinguish between regional dialects of the same language in a crowded, noisy room.
Which is why citizen science is so important.
Exactly. But the vocal behavior isn't just about territorial disputes. It connects to something far more profound about how these animals experience reality.
This is where we get into the transcript from Lynette Rudman's YouTube channel.
Oh, this is my favorite part.
It is wild. She's a local birder who spent time recording these calls. And in her field notes, she casually drops this observation that stopped me in my tracks.
Yeah.
She says, they tend to call more frequently about 24 hours before a weather change.
Just casually mentioning they predict the future.
Right. She observed a dry spell, and then suddenly an olive bushshrike started calling frantically nonstop all day. And the very next day, overcast and drizzly.
It's a phenomenon that has fascinated observers for centuries, but we actually now have the physiological understanding to back it up.
Lay it on me.
Well, we view weather through screens and satellites, right? But a bird is directly, physically coupled to the atmosphere.
Okay, I have to push back here. Even if a bird can sense a storm coming, why is it shouting about it?
It seems counterintuitive.
Yeah, a 33-gram bird in a heavy storm is in serious danger. High winds knock branches down. Cold rain drops your body temperature. Why not just hunker down silently? Is it like a warning to the rest of the forest?
It is highly unlikely to be altruistic. Nature rarely is.
Fair enough.
It's an evolutionary survival mechanism driven by deep physiological triggers. Birds possess an incredibly sensitive anatomical structure called the paratympanic organ.
A paratympanic organ. Okay. Where's that?
It's located in their middle ear, and it functions essentially as a biological barometer.
Wait, really? A barometer in their ear?
Yes. It detects microscopic drops in barometric pressure that precede a weather front. And it does this often, a full day before the human eye would notice a single cloud gathering.
That is incredible.
Furthermore, a bird's respiratory system is entirely different from ours. They have pneumatic systems, air sacs that extend throughout their bodies, even into their hollow bones.
Oh, wow. So when the atmospheric pressure drops...
Their entire body physically feels the shift. It's visceral. And from an evolutionary standpoint, a dropping barometer triggers a behavioral cascade.
Okay, so what is the shouting actually achieving?
The sudden burst of vocalization isn't necessarily them shouting, "Hey everyone, it's gonna rain." It's more likely a rush of adrenaline. They know a window of severe restriction is closing in fast.
So they're rushing to secure their borders.
Exactly. They vocalize intensely to assert their territory one last time, ensuring competitors are pushed out before everyone is forced into hiding.
It makes so much sense.
They might also be coordinating with their mate, ensuring they're in close proximity before the storm hits. And physically, that pressure drop triggers hyperforaging.
Because they might not be able to hunt in the rain.
Right. They have to consume as many calories as possible right now because for the next 48 hours, heavy rain and wind might make canopy gleaning completely impossible.
That totally recontextualizes the whole thing. We think of a weather change as like an inconvenience. You know, I have to bring an umbrella.
Yeah, right.
But for them, it is a recurring existential crisis.
Mm-hmm.
And the barometer in their ear is basically the air raid siren going off.
That's exactly what it is.
It proves they are so deeply integrated into the physics of their environment.
Yeah.
Which makes me think about how they interact with the other species in that environment.
Which is an interaction that completely changes depending on the season.
Right. We know they are fiercely territorial in the summer, screaming at rivals, holding down their turf.
Very antisocial.
Yeah. But what blew my mind in the botanical garden data is what happens when winter hits. That territorial aggression just completely vanishes.
It's a total behavioral 180.
The Garden Route Botanical Garden Guide notes that during the cold months, you will suddenly find the olive bushshrike moving through the forest in bird parties.
Bird parties. Ecologists actually refer to them as mixed species foraging flocks.
Mixed species foraging flocks.
Yeah, and it is one of the most elegant, highly structured cooperative strategies in nature.
The guide actually lists the specific birds in these parties. You've got the olive bushshrike, the yellow-throated woodland warbler, the blue-mantled crested flycatcher, and the black-backed puffback.
A very specific crew.
I read that list, and I immediately pictured a tactical strike team.
It really is.
Every single member has a highly specialized role. You've got the scouts, the point men, the muscle. But why do it this way? Like, if I'm an olive bushshrike, why wouldn't I just team up with 20 other olive bushshrikes?
Because of the principle of competitive exclusion?
Competitive exclusion, meaning what?
Meaning, if you flock with 20 birds of your exact same species, you all have the exact same 22-millimeter beak. You all hunt in the exact same layer of the canopy, and you all want to eat the exact same beetles.
Oh, you deplete the food source instantly.
Instantly, and the whole flock would starve.
You'd just be fighting your own teammates for scraps.
Exactly. But if you join a mixed species flock, your dietary niches overlap only slightly, if at all.
Because they all hunt differently.
Right. The flycatcher is grabbing insects out of midair. The warbler is probing different kinds of bark on the smaller branches. The bushrake is canopy gleaning in the dense foliage.
Wow.
You aren't directly stealing food from one another, but you reap the immense life-saving benefits of moving as a collective network.
And the botanical guide gives a very dark hint as to what those benefits are.
Ah, yes. The predators.
It says, keep an eye out for African goshawk and little sparrowhawk that lurk in the tree canopy, waiting for an opportunity to hunt the smaller birds.
That is the primary driver of the mixed species flock. Predator detection.
They need lookouts.
Exactly. We call it the many eyes hypothesis. In winter, food is scarce. A small bird needs maximum caloric intake just to survive the freezing nights.
Right, they have to keep eating.
But if you are foraging alone, Every single second you spend looking at a leaf for a spider is a second you aren't looking over your shoulder for a goshawk.
It's a deadly math problem. Eat and get eaten, or watch the sky and starve.
Exactly. But in a mixed species flock, you suddenly have 40 eyes scanning the environment from entirely different angles.
Oh, that makes so much sense.
The flycatcher is watching the open air above. The puffback is watching the lower branches. The moment one species detects the sparrowhawk, it gives a universal alarm call.
And they all understand it.
Yes, and the entire multi-species flock dives for the dense cover. The individual risk drops exponentially.
Okay, so the security system makes total sense. But does it actually help them find food?
Yes, through what is known as the beater effect.
The beater effect.
Imagine a flycatcher swooping erratically through the branches, or a warbler fluttering against the leaves while it probes the bark.
Lots of commotion.
Right. That chaotic movement disturbs the environment. A moth that was perfectly camouflaged against the bark suddenly gets spooked and flutters away.
And the flycatcher might miss it.
But the olive bushshrike, sitting perfectly still a few feet away with its precision tweezers ready, suddenly sees the movement.
Wow.
The other species essentially act as beaters, flushing the hidden prey out into the open. By operating as a cooperative network, the flock harvests significantly more calories than any of those birds could ever find on their own.
The bushshrike just sits back, lets the warblers do the chaotic work of shaking the bushes, and then calmly snipes the targets that reveal themselves.
It's highly efficient.
It's a brilliant, highly cooperative winter economy. And, this communal behavior sets a really fascinating precedent.
It really does.
Because if they were willing to cross species lines to survive the winter, it sheds light on how intensely they cooperate with their own kind when the stakes are highest.
During the summer breeding season.
Exactly. The breeding data reveals a social structure that challenges a lot of assumptions about avian behavior.
It's remarkably egalitarian.
It is. The Biodiversity Explorer source gets incredibly intimate with their family dynamics. Breeding on the garden route peaks in November. And the data relies heavily on one specific word. Both.
Both.
It says the nest is built by both sexes. They lay 1 to 2 eggs, incubated by both sexes for 18 days. And the chicks are cared for by both parents until they fledge at 16 to 17 days. It is a rigid 50-50 split of labor.
Which is definitely not the default setting in the animal kingdom.
It's not.
No, not at all. Very often, one sex, frequently the male, expends all his energy on complex mating displays or aggressive territorial defense, and leaves the actual incubation and rearing entirely to the female.
Right. So why are the bushrikes splitting it right down the middle? Is it just a cute evolutionary quirk, or is there a functional necessity forcing this egalitarian architecture?
Oh, it's absolute functional necessity. It is a response to the razor-thin margins of their ecosystem. Look at the clutch size.
1 to 2 eggs.
Exactly. 1 to 2 eggs. That is an incredibly low reproductive output compared to a bird that might lay 6 or 7 eggs in a season.
They're putting all their evolutionary chips on just 1 or 2 outcomes.
Exactly. It's a strict strategy of quality over quantity. They are investing a massive amount of caloric energy into ensuring those specific chicks reach adulthood.
And the incubation period is long, right?
18 days, which is a marathon for a 33-gram bird.
I can imagine.
You have to maintain a constant thermal environment for the egg. If one parent tried to do that alone, they would either starve to death on the nest, or they would have to leave to forage.
And if they leave, the egg gets cold.
Or it gets eaten by a snake. By strictly alternating, one parent hunts and refuels while the other holds the line.
But I want to talk about the nest itself, where they're actually holding this line, because they put all this incredible cooperative energy into building it. But the source describes the final product as a flimsy, untidy saucer made of fine, dry grass, leaf stems, and dried flowers.
Yeah, not exactly a glowing architectural review.
It seems completely contradictory. Why go through all that intense 50-50 labor just to build something flimsy and untidy?
Oh.
Why not weave a robust, impenetrable fortress?
This is a classic example of human aesthetic bias.
Human bias.
Yeah. We look at a perfectly woven symmetrical orb nest and we think, oh, that looks secure. That is good engineering. We look at a flimsy saucer of dead grass and we think, a stiff breeze is going to destroy that.
I mean, it sounds like terrible real estate.
But you have to identify the actual threat.
Okay.
The wind isn't the primary threat. They build these nests deep within the tangled forks of the canopy where the wind is already broken up.
So what is the threat?
predators. Snakes, monkeys, larger predatory birds. A perfectly symmetrical, robust fortress is visually conspicuous. In the organic chaos of a forest, a perfect geometric shape stands out immediately. To a predator, a perfect nest screams, "Hey, here is a concentrated source of protein."
Oh, wow. I see exactly where you're going with this.
I would strongly argue that an untidy saucer of dead leaves and grass isn't poor construction at all. It is highly sophisticated architectural camouflage.
It's designed to look like garbage.
Exactly. It mimics a random accumulation of forest debris that simply got blown into the fork of a branch.
That is so clever.
It doesn't look like a nest. It blends perfectly into the background visual noise. It ties directly back to their primary survival mechanism, visual stealth above all else.
The architecture of invisibility. That is brilliant. It looks messy because nature is messy. A perfect circle gets you eaten. A messy pile of leaves lets your species survive another generation.
Exactly. But here is the critical vulnerability in all of this.
There's always a catch.
Always. This entire delicate, highly synchronized life cycle, the precise 50-50 parenting, the low egg count, the reliance on dense foliage for architectural camouflage, it completely relies on a stable, predictable environment.
And as we know, the forests of South Africa, particularly along the coastal regions, are not stable.
No, they are not.
They are facing immense human pressure. Which brings us to the final, and perhaps most surprising, part of this deep dive. Fragmentation, adaptability, and the future.
This is where the story takes a turn.
Because up until now, we've painted a picture of a bird that is incredibly fragile in its requirements. The 600 millimeter threshold, the cathedral canopy.
And the SAB-2 data reflects that fragility initially.
It does. The atlas explicitly notes that the olive bushshrike has suffered local extinctions where deforestation has accompanied human population pressure and intensive agriculture, especially in the coastal regions of KwaZulu-Natal and the Southern Cape Province.
It's a sad reality.
When the ancient trees are clear-cut for farming or development, the bird simply vanishes, which makes total sense based on everything we've discussed. You remove the physical clutter, you remove the bird.
But then you have to reconcile that local extinction data with its overall conservation status.
Right, because the Biodiversity Explorer unequivocally lists its threat status as not threatened.
Which seems impossible.
How can a highly specialized bird that is suffering local extinctions be doing fine overall? The answer is buried in this incredible ecological research paper out of Durban by Ayler Smith and colleagues on forest fragmentation.
This paper is a massive plot twist. It basically forces us to redefine what the word specialist actually means in a modern context.
So the researchers in Durban went out and surveyed pristine patches of indigenous forest. But they also surveyed areas characterized as thicket-dense bush, or TDB.
Right.
This is secondary regenerating habitat. It's the messy, scrubby bush that grows back after an area has been cleared or disturbed by humans. It's not ancient. It's not a cathedral.
It's just scrub.
And what do they find? The olive bushshrike, this supposed snob that demands ancient yellowwoods, was recorded thriving in these secondary urban thickets.
It creates a core ecological tension. How can a species demand pristine conditions, yet simultaneously utilize a modified secondary urban thicket?
Is it just like toughing it out, like, well, this isn't ideal, but I guess I'll live in the scrub brush?
It's much deeper than that. The fragmentation study looked at the physical structure of these secondary habitats. We assume ancient forests are the only valuable habitat because the trees are tall.
Right.
But the olive bushshrike doesn't necessarily care about the age of the tree. It cares about the geometry of the environment.
The structural geometry.
Precisely. Thicket-dense bush, while lacking massive ancient trees, provides an incredibly high stem density and thick, impenetrable, tangled foliage at lower levels.
Yeah.
It recreates the structural complexity of a forest canopy, just closer to the ground.
That makes perfect sense.
If the secondary thicket provides the dense cover required to hide from goshawks, and if it supports a large enough biomass of beetles and mantids, the bushshrike's biological algorithms allow it to adapt.
It's the exact same hide-and-seek game, just played on a slightly different game board.
Furthermore, Batani's thesis on seed dispersal notes that species like the bushshrike are actually interacting with fleshy-fruited, invasive, or pioneer plants that colonize these disturbed areas.
Wait, really?
Yeah. They are expanding their resource base. They are far more resilient and behaviorally plastic than historical, rigid definitions of forest specialist would ever suggest.
I think that is a massive dose of hope. We spend so much time in environmental discussions talking about how fragile everything is. And yes, Clear-cutting an ancient forest is devastating.
Absolutely devastating.
But this reveals an incredible, stubborn resilience in nature.
It completely shifts the paradigm of urban conservation.
It really does. It means that urban greenbelts, those messy, tangled strips of woods between housing developments.
Or a place like the 16-hectare Garden Route Botanical Gardens sitting right in the middle of a bustling town like George.
Yes. They aren't just pretty parks for humans to walk their dogs. They are functioning, vital arcs for biodiversity.
Even a small patch of habitat, if it maintains the correct structural density, a mix of indigenous plants and established thicket can act as a stepping stone. It prevents a localized extinction from cascading into a regional one.
I want to bring this directly back to how we view our own environments. Because understanding the olive bushshrike changes how you look at a patch of dense, messy, overgrown bushes near your house or along the highway.
It really reframes it.
To a human eye, it looks like weeds. It looks untidy. You might think, ugh, the city really needs to clear that out. But to a highly specialized bird retreating from a rapidly changing world, that messy thicket is a sanctuary.
It's a lifeline.
It is the vital hunting ground. It is the geometric equivalent of an ancient forest, scaled down to survive the 21st century.
Nature does not care about our aesthetic preferences for manicured lawns and clear sightlines. Just like the untidy nest that keeps the eggs alive, a messy, tangled thicket is often the most biologically secure and productive environment on Earth.
Let's take a breath and zoom out to look at the incredible narrative we've traced today.
We've covered a lot of ground.
We started by defining the strict borders of this bird's world, that absolute necessity for 600 millimeters of rainfall to engineer the dense, dark canopy it requires to survive.
We examined its 33-gram body.
Yes, and its 22-millimeter precision surgical tweezers, perfectly adapted for high-stakes canopy gleaning.
We unpacked the paradox of its acoustic dominance, using sound to cut through the visual clutter of the forest.
And explored the biological barometer in its ear that allows it to sense atmospheric pressure drops and call out storms before a single cloud appears.
We looked at its brilliant winter survival strategy, joining interspecies tactical strike teams where flycatchers act as beaters and 50 pairs of eyes watch the sky for predators.
We marveled at its egalitarian summer romance, splitting the massive caloric burden of incubation 50-50 to build an untidy nest that leverages the brilliant architecture of invisibility.
And finally, we challenged the narrative of the fragile specialist, revealing a shape-shifting survivor that is holding the line against deforestation by utilizing the dense geometric complexity of secondary urban thickets.
It is a staggering amount of ecological complexity wrapped up in one tiny olive-green bird that you might live your whole life without ever seeing.
It's truly amazing.
But I want to leave you with one final, lingering thought to mull over, something that builds on everything we've just discussed. We talked about how the olive bushshrike can physically feel the barometric pressure dropping 24 hours before it rains.
Right, that paratympanic organ.
Yes, acting as an environmental sensor, tuning into a frequency of planetary physics that human bodies are entirely deaf to.
They are biologically wired into the invisible shifts of the atmosphere.
Exactly. So it makes you wonder, what other invisible ecological signals are firing off around us right now?
Oh, that's a good question.
What subtle shifts in the air? What chemical communications between the roots of trees? What magnetic fields are fluctuating every single day that we have simply lost the hardware to perceive?
We miss so much.
We rely so heavily on our eyes. We want the clean, binary X-ray. But if we just stopped, stood completely still in the middle of an untidy thicket, and actually listened to the world outside our windows, what exactly would it be trying to tell us?
That is the real deep dive.
Thank you for joining us on this journey today. We will catch you next time.